Okay, so let's go over the equation of a circle. Do you guys remember this before? Have you ever talked about this? Maybe in Algebra 1, did you go over the equation
Yes.
of a circle? Think so?
I believe you.
Maybe towards the end of the year, I'm not sure. So let's talk about the equation of a circle. Circle is a pretty simple concept. This is one of those things like, you just put it on your study sheet for the test and just make sure that you understand it. So this is what the equation of a circle looks like. Now, anytime you have the equation for some type of figure that you're going to plot on a graph, that equation will always have, if it's a two-dimensional graph, it'll always have an x and a y in it, right? So like when we did the equation for a line, remember what was our standard equation for a line when it was slope-intercept form? Anybody remember?
Y equals mx plus b.
Y equals mx plus b, right? And what we would do whenever I asked you for, did we do that in this class? It was, right? I've done it in pre-calc too, but I was pretty sure we must have covered that in here. Right, so we would have to figure out what the slope was, and we'd have to figure out what b was, right? So our final equation that we would come up with would be something that looks like that, right? Where x and y are still x and y, but we plugged in values for m and b, right? And so it's the same thing for the circle. When you have the equation for the circle, it's going to look something like this. All right, maybe like that. And so the h and the k will have a value, the r will have a value when you get that final equation of a circle. And the cool thing about this is that you can just then look at this table, not this table, you can look at this equation, and you can, from looking at the equation, figure out where the center of the circle is, and you can determine what the radius is, okay? So the center of the circle will be the point HK. Yes?
Shouldn't y plus 3 be squared?
It should. Wow. I'm going to, you brought me a coffee and two things right off the bat here. So I don't give out the plus twos very often, but I'm feeling generous. The coffee's got my hyped up on caffeine from all the coffee. So the center is HK, and the radius in that first equation is just r, right? And so that means if we have an equation for a circle that looks like this, then the center is going to be, what's my x coordinate for my center going to be?
2.
It's going to be 2. Here's the tricky one. What's my y coordinate going to be? Yes, 80.
-3.
-3, right? So it's -3 because, remember the equation here for the circle has minus in front of the h and minus in front of the k. So if you've got a plus in between the y and whatever the number is there, then the value that goes in the coordinate is going to be negative, okay? And then for r, so this is the center, and r is just going to be the square root of whatever's on the end down there, so the square root of 25, so r in this case is going to be 5, right? So if I asked you to plot a circle that had this equation here, what would you do? You would say, or if I asked you to graph it, you would say -2, nope, sorry, +2, and then so positive, go over 2 and down 3 is the center. So we're down here for the center, right? That's my center point. And then I go 5 in every direction from that point, as far as up, down, left, right, to draw the edges of the circle. So this thing would have to extend all the way down. 1, 2, 3, 4, 5. So I've got a point down here. 1, 2, 3, 4, 5. I've got a point right here. It's got to go over 5 places to the left. So 1, 2, 3, 4, 5. I've got a point right here. And then 1, 2, 3, 4, 5. I've got another point out here, right? So my circle would look something like that there. If I asked you to graph that circle, okay? Your circle doesn't have to look perfect, but what I'm expecting to see is the center point in the correct location, and to see some points that are 5 units away from that center in each direction, right? Does that make sense to everybody? Anybody want me to review that again or have further questions about that? So this, yes.
What section are you on?
This is section 10.6. So what if I just gave you, like they do here, what if I just said, hey, I've got a circle that has a center at -4, 0, and it has a radius of 7.1. Give me the standard equation for that circle. So what would the standard equation for a circle like that be? So this is our standard equation of a circle. Right? So we just plug in the values that we have. This is going to be x. What's h going to be?
+4.
It's going to be +4. Let's just do it like this, just to make sure we don't make any mistakes with our signs. Okay? We're going to say x minus, because that's what's in our equation. We're going to put h in parentheses and say -4. Okay? And then we're going to say all of that plus y minus, there's no sign in front of that, so we're just going to put 0 down there, squared equals 7.1 squared.
Solid square. Oh.
And so you're right, this turns into x plus 4, so we would write x plus 4 squared plus, we can just throw the 0 away and just say that this is plus y squared. Everybody comfortable with that? And then 7.1 squared is 50.41. Just did that in my head real quick. 50.41. So that's what I would expect you to write down if I asked you for the standard equation of a circle, given those values. Okay? Are we following that? Now, what if instead of giving you that, what if let me just, while we're talking about that, let me just point out that what would the standard equation for a circle be? How would my standard equation change if my circle, if my center for my circle was at the origin of a coordinate plane? What's the origin? 0, 0, right? So I would basically be plugging in a 0 for h and a 0 for k. So if it's at the origin, the equation for the circle becomes that. So just make sure you see that. A little simpler.
Wouldn't that also be x plus y equals r?
No.
Or no, never
No,
mind.
yeah, that wouldn't
Never
work out.
mind. Yeah.
Okay, so I could give it to you like this, or, is that what they do in the next one? They do. They tell us that we have a circle, and there's a point on that circle that lies at 1, 2, and that this circle has a center at 5, -1. So what's the piece of information that I need to be able to just plug this in directly and get the equation for the circle? Yes, Aiden.
The radius.
We're missing the radius, right? Does everybody see that? That's what I gave you here. I gave you the center and the radius. Here they give you the center, and they give you a point that's lying somewhere on the outside of the circle, right? We've got a point over, they've given us this, and they've given us this point here. What we need to still know is we need to know this distance here. Well, do we have a way to find the distance between 2 points on a coordinate plane?
Yes.
We
Simple
do.
algebra.
Huh?
Simple algebra.
Simple algebra, says David.
Yes.
Okay.
Okay.
We will use algebra to find it, but what's the equation that we're going to use to find it? Somebody that's not on the board yet.
This is the distance formula.
Wait a minute. Did you whisper that to him? It is the distance formula. You're right. And what is the distance formula, Jackson?
Oh gosh.
Oh yeah. see if Aiden whispers that to him.
It's
Is it-
it's long like square roots in it.
Yeah, it's got the whole thing's over square. Let me tell you how I remember the distance formula. Okay, you can write this down on your cheat sheet. And so that's always the way to remember the distance formula. So you're not going to have that on the SAT or the ACT, right? So the way that I remember the distance formula is something that I hope that we always remember is the Pythagorean theorem. What's the Pythagorean theorem?
A squared plus b squared equals c squared.
That's right. A squared plus b squared equals c squared. So if you think about it, if I have a point, these 2 points here, right, on a coordinate plane, and we'll say this point is x1, y1, and this point is x2, y2, all right, then I could do this on my coordinate plane and make a right triangle, right? And so this is the distance that I'm trying to find, my distance d. What is this distance here? Well, this distance here is the difference in my x values. So this distance is x2 minus x1. Does everybody see that?
Yes.
And the distance here is the difference in the y value, so that's y2 minus y1. All right? And so if I use the Pythagorean theorem, then a squared, which is x2 minus x1 squared, right? Pythagorean is a squared plus b squared equals c squared. For these values here, a is x2 minus x1 plus y2 minus y1 squared equals c squared, which is d squared. And so if I want to find d, I just take the square root of the whole thing. So I'll say d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance. All right? So to me, that's the easy way to remember, so I don't have to remember all this stuff. I just think about the Pythagorean theorem in my head. All right? But again, just make sure that you put that on your cheat sheet or your note card that you're using on your test. So we've got 2 points now, and we can find the distance between those 2 points using that formula there. So we can say that the distance between those 2 points is the difference in the x values, which we'll say is 5 minus 1 squared, plus the difference in the y values, which is -1 minus 2 squared. So it's the square root of 4 squared plus -3 squared. And so we get 16 plus 9, which is 25, and the square root of 25 is 5. All right, so that's our radius. And so now it's just a matter of plugging these values, just like we had before, in our equation of a circle. So x minus h, remember this is our center point, so x minus 5 squared plus y minus k. K is already negative here, so we're going to change this to a positive. Y plus 1 squared equals, remember this is not r, this is r squared. So we found r to be 5, so we'll square it, and we say 25. So that would be the formula for the equation of that particular circle. Questions about how I got that? Yes, Paul?
Is 4 supposed to be the 6th power?
Of course. I mean, what was your question again, Paul?
Is 4 supposed to be 4 to the 6th power?
Looks like it's squared to me, Paul. I don't know what's going on in your mind, but you spoke in class, so I'll write your name on the board. All right, thank you very much. I think we've done everything. There's a word problem there where they talk about theater lighting, but you're just kind of applying the same stuff and figuring out which points would be included in the circle that's formed by this equation that they give you. So that's really all that we need to cover for 11.6. 10.6, thank you. And so let's go to 11.1, all right? This kind of cool picture at the beginning of chapter 11. I wonder where that is. Does it say where it is?
Rocks.
I hate it when someone shows a cool picture and they don't tell me where it is.
The Giant's Causeway in Ireland.
Oh, there it is. The Giant's Causeway. Okay, I'm sorry. I apologize to my book. You did tell me. Just didn't see it. In Ireland. Has anybody ever been to Ireland?
No.
No, me neither. All right, so angle measures and polygons. Sounds like fun stuff.
You say so.
This is the whole reason you took the class, right? You were like, I want to do fun stuff like that.
Yeah.
So,
Our whole year led up to this.
So, we've got a bunch of polygons that are here at the beginning of the chapter and just kind of jumps immediately into theorem 11.1. We remember what a polygon is. What is a polygon?
A
Yeah,
shape the size. And
right. That's how the basic definition of a polygon.
Shape and size.
What is it? Try it again.
it's not rounded and it closes and it.
Yeah, okay. Cal, you want to give me something a little more technical?
No. Wow.
It's no.
So it's not rounded. That's true.
It has to connect.
They're all lines. It's made up of lines, segments. Yeah, Mary.
At least 3 sides.
Has to have at least 3 sides, and they all have to meet one another. All the lines have to, or the line segments have to meet one another, right? So there can't be any gaps in it, right? So yeah, that was kind of a team effort there. Let's see, Cal, Cameron, Camille, you haven't said anything yet?
I did.
You did? What did you say? Did you say I like
That's what they
Buc-ee's?
did.
Is that what you said?
No, but
But I can tell you like Buc-ee's. I just thought that. I was at Buc-ee's the other day. They had the cheapest gas in Warner.
Well, I said that they had to like close. And
Oh, did you? Oh, you said something distant. All right, so Mary was in on that. Cal. Well, but you already did one more. All right, now I don't feel enough. I want to count that. All right, it's like this. But does that make sense? Everybody has to be at least 3. So a triangle would qualify as that. You know, any of these shapes here, as long as they close. I mean, it could be anything.
That one doesn't close. Oh.
There we go. All right. And then you just count up the sides to determine what type of polygon it is, right? And we talked about things like convex and concave. You guys remember that? If it caves in anywhere, then we say it's concave. Yes. Otherwise, it's convex. So this guy would be concave. These would all be convex. But theorem 11.1 says this: that the sum. Theorem 11.1. The sum of the measures of interior angles of a convex, again, what do I mean by convex? It means it doesn't do this. It means that with a convex one, I could draw a line through every side, like this, and that line would never go through another side. Okay? That's one way to think about it. Or you could just think, hey, it caves in on one side. But you see how here, if I were to draw a line through this, it goes through this side on the other side. So that's how one way we could test to see if it's concave. These are all convex. So we're only talking about convex polygons. So the sum of the measures of the interior angles, a couple of key things I want to point out in this definition. It's the sum and its interior angles. All right? The sum of the measure of the interior angles of a convex n-gon. We're saying n-gon just because it doesn't matter how many sides it is. It's always going to be this, n minus 2 times 180 degrees. All right? And then there's the corollary. That's an O right there. I'm going to that. Corollary, right? Yep. Corollary to theorem 11.1, which says the measure of each interior angle of a regular n-gon. I'm going to underline regular because that's really important in this one. Is, now what does regular mean? Anybody remember? What's so funny? What is it? Is that what's going on here? You guys making music with your sniffles?
I have a sniffle gobbler.
Sniffle battle. All right. I get it. I've been sniffing for many weeks now. So, but it is kind of funny when you just get quiet and listen. Yes.
Can we use the wheelie thing? I
Yes,
can't
sure.
see.
The willy thing. I like that. That's the technical term. Willy thing.
Right?
So, what's a regular polygon? Yes.
It's where all the sides are equal.
That's right. So the length of all the sides are equal, right? Did you not agree with that, Mary? Okay, all right. It's like, I think that's what it is, but Mary made a weird face, so now I'm not sure.
And the angles are equal.
Yeah, okay. So basically it would be like, for this triangle, we would have to say that, right? An equilateral triangle would be a regular polygon. Or if the length of all these sides here were the same, it would be a regular polygon. So for a regular n-gon, we can say that because so since all the angles are the same measurement, we can simply, because of this theorem here, say that the measure of an individual angle is 1 divided by n times n minus 2 times 180 degrees. Or you could write that another way that you could write that would be n minus 2 times 180 degrees divided by n. So in other words, it's the measure of all the sum of all the angles divided by the total number of sides. All right? That makes sense. If all the angles are equal to one another. All right? So they give us a couple of problems, example 1, example 2, that we could work, and example 1 has a polygon with a bunch of different angles in it, right? Except for one, and it says what's the value of x for that particular one. So the angles that we have are 88. We're just going to write all those down. 88 plus 142 plus 105. Just kind of pick a random spot and going around. Plus x plus 136 plus 136 plus 88. All of that stuff there has got to equal. If I add all the angles up, it's got to equal that, right? So n minus 2, yes?
You did 88
I did, didn't I? Let's just erase that. All right, thank you. Thank you, Liana. You're saying it so politely, right? But then secretly laughing on the inside. I can tell you were. So that's right. And we say that it's n minus 2. So what is n? It is the number of angles. Well, it does turn out to be the number of angles, but it's the number of sides, actually, right? So this one here has 1, 2, 3, 4, 5, 6 sides, which makes it what kind of shape? A hexagon, right? So it's 6 sides, so we would say that all that has to equal 6 minus 2 times 180, right? How did I get that? I just plugged it into this formula right here, right? So we add them all up and we get that value there. And so that means that if we add all these angles up, we get 607 plus x. And if we do the math for this, 4 times 180 gives us 720. I've really got to move this bag before I break my neck. And so then x is going to be equal to 113 degrees. Okay? Got it?
Yes.
Yes? Okay. Let's see. I don't know if I want to try to do example 2 yet. I'm going to go ahead and move on to the next 2 theorems, and if we have time, I'll come back and do example 2.
Wait, don't you have to?
Don't I have to what?
Don't you have to divide it by the number of?
No, I do if I'm using the corollary,
Oh.
right?
Oh.
I'm just using the first theorem.
Yeah.
Okay? All right, so what does theorem 11.2 say? Theorem 11.2 says that this is for the exterior angles. That's why I underlined interior right here. The sum of the measure, again, it's the sum of the exterior angles of a convex polygon with one angle at each vertex is 360 degrees. Okay? So for the interior angles, we could say all the interior angles add up to be that. But for the exterior angles, they have to add up to be 360 degrees. And what do I mean by exterior angles? Well, if I draw a shape, like maybe this shape here, all right? My exterior angles, if I extend a line out right here, and then we'll just do that all the way around. Okay? Then the angle formed in all of these places here would be what my exterior angles are. And I did that, I shouldn't have drawn the same line for each one because they all have potentially different measurements. There we go. But all of those angles there, right, will add up to be 360 degrees for a convex polygon, okay? And so we could say they have that weird kind of shape there on in example 3a, and what it means, they've got all the exterior angles exterior angles listed for us. So we can say x plus 2x plus 2x plus 4x plus 3x. All of that has to equal 360 degrees, right? So that's 5, 9, 12x equals 360 degrees. So x has to equal 30 degrees. Or x equals 30, sorry, not degrees. And so for that particular problem, I could ask you I could say, tell me what all the exterior angles are, and then you have to plug the x back in and figure out the measurement, right, for that. Does everybody see how I found x for that one? Does everybody have their book? I didn't want to take the time to write it down since we're kind of short on time. Does that make sense? Make sense? No? Question? You do have a question or you don't? Okay.
It makes sense.
Okay. Let's do the corollary and we will be done. What's the corollary to this? It's similar to the other one in that it has to do with a regular polygon. And it says the measure of each exterior angle of a regular n-gon is 1 over n times 360, or 360 degrees divided by n. So if I told you this was a regular polygon, right? If I had marks like this all the way around that said this was equal on every side, then how would you figure out the measure of each angle? Yeah?
You just do 360 divided by the number of sides.
Yeah, so there's 5 sides on this one, so I would just say 360 divided by 5, right? So whatever that turns out to be is what the measure of each exterior angle is. Okay? Simple enough? Cool. All right, so I will give you guys a homework assignment for these 2 sections. And like I said, we'll have 2 more sections that we cover next week, but I'll also hand out the test for 10.1 through 10.5 next week. All right? And per Grace's request, I'll try to get you guys a review sheet as well. All right? Y'all have a good week.